Okay, I posted a markdown file. So markdown file, if you download, you can open the markdown file. So file, open file. And you have to find the directory that you downloaded that markdown file. Markdown file is RMD extension. This is a R and markdown, and it contains the formula, right? So you can see. Maybe you have to run this one. So as you can see, the package markdown neat R and then OLSR are required but not installed. So you can just simply click the installed and it will install all the required package. So this markdown file is the pretty good tool if you wanna create the report using a lot of R cases. So because you can create like a document, and then you can also include the R formula function in between. Okay, so I will use a visual. So this is a source. This is a more like a text version. But visual version is something like that. So you can see this is like a word processor. And inside of that there is the R code, and then actually it can be learned. So we just installed all of them, so you can just learn. And this is a learning. So this is just warning, so you don't have to worry about. And then you can just use the data file CEO salary 2 from the package, Woodridge package. So we can bring the data. You can just simply click and then it will learn our code. And we have a data set here, 177 observation with 15. If you take a look at it, so you can see this data file. Interesting is a salary. Usually we trying to predict the salary using age and college, the CEO graduate college or not, graduate school or not. I don't know exactly what is the is company tenure or CEO tenure, sales, profit, market value. So here is L salary. Salary is a log salary. L sales is a log sales. L market value is the log market value. This is the company tenure square and CEO tenure square and performance. It's a profit margin. Okay. So we want to go back, and then we just bring the table, and then we can create the linear model. So model is the linear model. Salary is age plus college or graduate plus company tenure, CEO tenure, salary, profit. So I exclude all the log things, right? And then you just run it, and you can see the result here. Right? You can see the result is each coefficient, and you can see the probability. Actually, age is probably is a high, right? Everything is pretty high. You also see the R is just 0.17. F test p-value is significant, so you can tell this is a significant. but this is the only one which is significant, right? And so on. Multicollinearity, when we trying to find the multicollinearity, you have to learn this model and you have to have other model. That's why I include everything here. And then bring this model into here, the VIF function. And if you learn the VIF, then you can get a VIF of age, VIF of college, graduate, and so on. As you can see, the profits and the market value, the VIF value is greater than 5. We don't know what other value is related to the profit, but this 7.67 means profit has a high correlation with some others. Maybe not only one, maybe some of them. Three other value together. I don't know. It doesn't tell you which one, but clearly profit has a high correlation with the other value, and market value also has a high market value. So you can think of if there is no other reason, you can drop the profit and market value here. You can draw the residual. So using the residual function, you just type in the model, then you can get a residual value. And then you can draw the sales versus residual, or log sales versus residual, or the coefficient tenure versus residual, and so on. So you can draw as many as you want. Where is the graph? I should be able to see the graph here. Yeah, now I can see the graph. I don't know. To see the graph better, I will make this one. So this is the what I draw, the residual versus the CO tenure, and this is a residual with a log sales, and this is a residual with just sales. Oh, here, that's why. Okay. Yeah, oh my God, I learned everything here. This is the what I originally. This is the what I tried to draw. Yeah, the previous one is not one. This is the right one. And here, as you can see, most of data is all together here, and then we have something pretty outside here, right? And this is also pretty outside. And you can see the same thing here. This is pretty off, right? This is pretty off. So what you can do is, can I find out which data point is this one? And get rid of them. Also, this one seems pretty off, so you can get rid of them. So what you can do is, from the residual, because this is a 3000 or higher, this only one point is higher than 3000, right? So I can find out, if you just do this, then it will tell you what is the index and what is the value of the residual. Right? Here, what you can do is why this one doesn't tell you anything? yeah, this one, I run this one, yeah, and then this one. That's why I see all the off things. And then if I run this one, then I should see, yeah, this, I use the same variable. That's why this is the what I find out is a 103rd data point has a 490 data point. This is this point because I choose the residual is greater than 3000, right? This is so 103rd one is the kind of the outlier, and also this one. This one is the sales are greater than 50,000. Sales are greater than 50,000. So you find out where is the sales are greater than 50,000 in this data set. You can find out it's a 44, right? 44th observation has a sales greater than 50,000. So what I'm going to do is taking out, this is the taking out 103rd observation and 44 observation I'm taking out. Here the minus sign means I'm going to taking out. And that's row by row. I will taking out 103rd row and 44 row. Then I'm taking out 10th column. So what is the 10th column? Why I'm taking out the 10th column and then create the new data set without 103rd row and 44th row and 10th column. So basically 10th column is 1, 2, 3, 4, 5, 6, 7, 8, 9. 10th column is a log of salary. But salary is our Y value. So I cannot use a log salary as our independent variable X. So I'm taking out this log salary. That's why this is minus 10. So I created a new data point. It's a data set. It's a CEO salary 3, right? And then I'm going to do the same regression with a new data set, which we taking out the two outliers. Then as you can see, our adjusted R-square is improved pretty much. So it was a 0.17, now it's a 0.29, which is way better. And if you look at the proper p-value, now we have many values are the significant, and this one and this one. So by get rid of the outlier, we improved our model a lot. And then now if you run the multi-collinearity again, yeah, still this is a profitable, profit and the market value has a high correlation, so we can take it out. And now if you look at the residual plot, now we don't have a outlier here, right? It's better. Now I will show you how we use a model selection. So first, even though the forward selection starts from the no independent variable at all, but still we have to create the full model. Full model, if you just type the dot here, it will include all possible variable here. That's why I taking out the log salary first. And then you can use OLS step forward and adjust it all and the full model. So if you just run this one, yeah, you can see the procedure, right? Step 1 is the base model, which is the nothing in there, no independent variable. And first one was selected, this log market value was selected, and R-square, adjusted R-square is 26.9. And then the second variable chosen is CEO tenure. So you can see the adjusted R is increasing, and then stop. Okay. So I don't know, actually we have a 14 columns, so one of them is our Y value. So actually we have a 13 possible independent variable, X variable, 13X variable. right? 14 column, one of them are y, and all for 13 is the possible x variable, but actually you adding the 8 of them and you stop. Probably the ninth one, if you add, your adjusted r will goes down. R square will goes up, but r adjusted r square will goes down. So this is your final variable. Okay, and backward elimination is the same thing. So now, I use just p value instead of adjusted r, and you have to use what is the p value? The criteria p value is a 5%. You can use a 10% or you can use a 1%. However, if you run this one from the full model, everything else, as you are dropping the variable, right? That's why r square is going down. R square is going down. However, adjusted r square is going up, right? As you can see here, since we use the p-value as a criteria, so even though adjusted r is going up and going down, as you can see here, this is the maximum adjusted r, but it's going down. But it won't stop here from college, because the p-value still there is the variable that has a greater than 0.05, but p-value or the adjusted r is all keep changing when we drop the one variable. So it keep running the regression again and again and checking again and again, and then it stopped at 8. So dropping 8 variable. Right, so that's why we have only 1, 2, 3, 4, 5 5 independent variable model. This is our final model using the p. But if you use instead of p here, if you use the r square model, then the result can be different. Stepwise is we are using both, but I will use adjusted r, and then you also use a full model. If you learn, you are adding, subtracting, you are just keep adding, and then once you it stops when you add the 8 of them, right? And you cannot find any better one to add anymore. So result will be the same as the forward, but that's the kind of the coincidence. So it's not always the same. You can have a different result. Depends on the what you use. You can have a different result. I can try here. I can add the backward OLS step backward adjusted R, and then I will use a full model, and I can run it again. Then we will have a it takes some time because the first one is just the same one, using the p-value one. So we end up with this 3 variable model. However, if we use r square, right, we end up with 1, 2, 3, 4, 5, 6, 7, 8 variable. So it dropped only 5, up to 5. This is the highest r square. If you drop another one, r square, adjusted r square goes down. That's why it stopped here, dropping only 5. So it having 8 variable, right, model, because that maximize the adjusted r. So depends on that, depends on the method and criteria, you will end up with a different model. Stepwise, yeah, you see the stepwise. Stepwise also you can use a p-value and all possible cases. Actually, this one takes a really long time. Yeah, okay, now it's done. It takes less than 10 minutes, but yeah, I think it's more than about 5 minutes. Actually, the result, the different thing is from here is you don't have to save the result. You can just run the function, then you got a result. However, this case, all possible cases, you have to save the outcome as a one variable. Actually, this is not contains only one number. It contains a lot of the information. So from here, so all possible is the outcome file. Inside of that, there is a result. Among the result, I want to find the maximum variable, maximum number. So why I do this is I want to find out which, actually there's, as you can see, there are a lot of them. Among them, which one provides the highest, maximum. So I want to find out maximum value first. Once you got a maximum value, and then I want to find out where is that maximum happens. And then I just show up. And as you can see here, this is I can see only 3 column out of 15. So n variable is a 5,812. Is it 7,000? I don't know which one is the number, but you can tell there is more than thousands of the regression. And then this is the variable this model choose 1, 2, 3, 4, 5, 6, 7, 8 variable. Maybe this is I'm not sure this is the same as this one or not. Looks same, but yeah, you have to check is it exactly same as this one or not. And then if you keep moving, the R square is 41%, and then adjusted R is 38.5. Yeah, I think this is the same model. Here adjusted R is of 3.86, so yeah, this is the same model. And you can see, yeah, you can tell what was the adjusted R, what is R square, and what model they use, 8 model, right? This is the X independent variable they choose. So this case is they run the regression with all possible combinations, and then they didn't give me just the best one. They give me the whole result. That's why I have to look for what is the best one, and then you find out the result. This is the best one. Okay, that's it for this chapter.